So we've seen halogen-containing alkanes already. For example, when we looked at the reactivity of alkanes, halogens were one of the few elements or chemicals that would actually react with alkanes to form halogenated alkanes. And also, when we looked at the reactivity of alkenes, when chlorine or bromine reacted with an alkene through addition, then 1,2-dihaloalkanes were formed. So we've seen these already. We're just going to look in a little bit more detail at their nomenclature. So the historic or common names of these halogenated alkanes are named by looking at the alkane group as an alkyl, and then the halogen ends in an "ide." So if we look at this example here, CH3Br, the alkyl group is methyl, and then we have bromide. So this would be called methyl bromide. You're mostly going to be held responsible for the IUPAC nomenclature, which is very similar to the way we've been naming. We identify the longest carbon chain that contains the substituent, and then we number, so we have the smallest number possible. So here at our first example on the far left, our longest carbon chain has 3. Our chloro is on the end, so we assign that carbon that is bonded to that chloro the 1 position. So this is 1-chloropropane. And here we have a hexane with 6 carbons, and we have a substituent that is 1 carbon in on both sides. So we have a methyl that's 1 carbon in, and we have a bromine that's 1 carbon in on the other side. So no matter which way you number it, one substituent will be 2, the other will be 5. How do you determine which gets 2 and which gets 5? You give the smaller number to the substituent that comes first in the alphabet. So this would not be 2-methyl 5-bromo, it would be 2-bromo 5-methyl hexane. And then if our halogenated compound only has 1 carbon, of course we don't need to number it. So for example, CHCl3 is going to be trichloromethane, and that has a common name of chloroform. And let's just take a look at an example of a halogenated aromatic. And we've seen that before when we looked at naming of substituents on benzene. But this is a fun example. It is thyroxine, which is a thyroid gland hormone. And you may have heard that you need iodine for your thyroid gland, and this is one of the reasons why this molecule, this hormone, requires 4 iodine atoms per molecule. Okay, so now that we've reviewed how to name these halogenated hydrocarbons, go ahead and take a look at these 2 examples here and pause the video and go ahead and name them. So if we look at the example on the left, the longest chain is 3 carbons no matter which way we go. I'm just going to go straight left to right, but we could go up a branch, it doesn't matter. Regardless, the longest chain is 3 carbons, which means it's propane, and the 2 carbon has 2 substituents on it, a bromo and a methyl. So the name of the compound on the left is 2-bromo-2-methylpropane. You got that right? Give yourself a pat on the back. And the compound on the right, the longest chain, is 4 carbons, regardless of how you look at it. And we want to give the substituents the smallest possible number, so it is a 2 carbon that has the 2 substituents on it, chloro and a methyl. So this is 2-chloro-2-methylbutane. If you got that right, give yourself a pat on the back.